All right.
Thank you.
So then you can go through, you can look at, this is just, again, this is their sort of their overviews, the flow rates, the outputs, what you have set for the outputs, sensor setup, and then if it's a formulation mode, the formulation details. So, and then over here on, I don't know how to get rid of this thing on, okay, sorry. All right, over here on the left, down at the bottom, or up at the top is if you click if you want to create a new protocol, and then down at the bottom are just some of the other pieces like run. Then you've got an edit and copy. So one of the things that this allows you to do, if, for example, you have variable output volumes each time you do a protocol, but you don't want to change and reset the parameters every time, you can come in, click that protocol, hit copy, it'll pull everything up. Then you could go in and say, well, in this case, I have 1.5 liters instead of 1 liter, and I'm going to fill 15 outputs instead of 10, so that you wouldn't have to start from 0 every time for that. But we'll just go ahead and click new here on this. All right. So then what we have here, the protocol number from a data integrity standpoint, every time you create a new protocol, it's going to log that. So this is the system protocol number, and then the protocol version number. And then you can use your protocol number or name in here. It's just a free text. I'm just gonna pull the keyboard up again, just put a couple of pieces in there, and then you can write a description. Again, this is a free text area for the description. And then you'll see down here below, you have, in this case, the operation. So the system, we can show you how you have manual control of all the valves and the pumps. So you can do quite a lot of just set your own connections up and run a fluid path, transfer material from one thing to another without going through all of these protocols. But if you want to use the pre-programmed sort of available operations, that's what's down here in this part. So those three options are just a straight fill, where you're taking material from your sources and transferring it to an output. A formulation, which you're taking material from your sources, you're transferring it to the mixing system that we have and leaving it there, or a formulate and fill, which would be the same, but then after you formulate, then it'll go into your outputs. So sort of like you could do cryopreservation media and then directly into your outputs using it that way. So we'll just do a fill, hit next. Now, in this case, I've already got this connected. So the first thing it's asking you to do is to tell the system how much volume is in each of the potential source positions. So you only have to use the ones you want, and it's already grayed out until you put a volume in there. So I'll pull up the number pad. I've got about 500 mils in my source bag. And the only reason you input this is just so that as you're creating the protocol, it won't allow you to try to fill more outputs than you have available from your source. So the next screen then, this is going to be to establish your fluid transfer rates. So priming, the way the system works here is you'll be able to see when we run, but it primes the entire system past the outputs to a bubble sensor and then reverses to fill one at a time. Then when you finish with that 5 set,
Hoping if you still having problems, grab a parent, teacher, or a geeky computer friend. The geeky computer friend is someone who knows how to work computers. Just a geek, smart people.
Keith, I think you
just have to.
sorry.
was that a question?
No, I think Keith just went in and didn't have his microphone on.
Oh, okay. All right. So anyway, one of the key elements of the fluid pathways, the way this works is that because the way it primes and purges the line, you end up with very little holdup volume in the fill set, in the transfer sets. So that'll become a little clearer when we actually run it. You see what I'm talking about there. But on prime, we usually recommend a very slow prime rate, mostly so that we can avoid bubble creation, which bubbles are like a nightmare for small tubing sets. The output volume flow rate. So this is how fast we want to fill the outputs. So the output and the sample flow rates, that's for your general outputs. And then sample is basically if you want a second flow rate. So in this case, I'm going to do a protocol with bags and then vials, 2 ml vials. So if you're filling a 2 ml vial, for example, you probably don't want to fill it at the same rate you're filling a 500 ml bag, just because the vial it'll spray back up into the top, whatever you get. So I'm going to actually, on the bag fill rate, I'm going to put this at 500 mils per minute. And then on the 2 ml vials, I'm going to put that at, let's do 25 mils per minute. Purge, just like the prime, you want that to go slow to try to keep the fluid running together. So this is just examples. You've got a lot of different control on that. So now this is going to go to the number of outputs that you're going to have. So I'm actually here going to have 2 outputs. So that'll be a total of 10 units. The first one here is going to be CSV2, which is our cell seal vial 2 ml. And then we're going to put 1 ml in each of these. Like I said, I don't know what the engineers have done to the system, so I'm hoping all the calibration and everything is right. So hopefully these will look good.
And this could be saved in as a protocol or like pre-input.
That's
ahead
right.
of a batch. And then back to the calibration, I guess there shouldn't be a need to calibrate this device.
There should not be a need to calibrate it. Nope. And it's so far we have not had to do that. We do have the option, if your sample, if whatever your material you're processing is, has really unique properties, maybe it's really, really viscous, or maybe something about the way your setup is where, you know, the gravity or the back pressure or something impacts the accuracy. We have the ability to go in remotely and we can have you collect data on the process, give us those values, and then we can give you an update to the constants for the flow factor calculation. So, but it doesn't really need calibration on a regular basis.
Nice.
Okay, so then we generated that first one there. So that's consumable number 1. Now the next one, now it gives me the chance to go to consumable number 2. In this case, I'm going to change it so it's not going to be the same. I'm going to go to the 50 ml bags that we have. And so here, let's just put different volumes in here so that you can sort of see how you can do that.
Now, if you were trying to do, let's just say 200 of the same vial, you could just duplicate those consumables.
Yep.
I guess. Okay.
Yep, that's exactly right. You basically just say how many it is, and then you can just sort of go through and duplicate it, and it should be the same. I think that's the regenerate outputs, I believe. We'll just kind of keep going.
Yeah, if they're all the same, you would just have to do check the common fill volume on the very left, and then just generate outputs, and every single output should be generated with the information that you put in that first starting consumable.
Nice.
So I want to point out that there are little sample checkmark boxes underneath each of those positions. That if you were to click one of those, check mark it, that would be the one that would be filled with the sample, the flow rate that you input for the sample.
Which is what we did in this protocol because I wanted to fill the bags quicker than I'm filling the vials. So I went back to the first one with the vials and clicked sample so that that'll give me the slower flow rate. Whereas on the bags, we've got the higher one.
Quick question though, if we were using the cell seal vials that have the weldable tubing, where you're increasing the distance on there, would we also need to change the volume, or does it just push air through after it gets a certain volume in the line to do the fill?
So the system comes with the pre-programmed consumable sets that take into account the length and the inner diameter of the connecting tubing. If you're using like a custom configuration, or if you were using one that had Cell Seal Connects connected to it, well, the Cell Seal Connects connected to it, we'll probably, when that is something that's available, we would have that as a pre-generated update on the software. But if you're creating your own, it gives you the opportunity input that information. So you don't have to modify the volumes you program. It'll automatically adjust how much it pumps.
That's awesome.
All right, so I think that's it. I've got next now. So that saved everything for me. I'm not going to turn on any of the sensors right now, just because it's, bubble sensor. It's got a pretty fine resolution on that. I believe it's detecting something at like a 5 microliter bubble. So on a small volume, that's important, but on a bag, it's just going to be data in your batch record that may not be all that useful. We've got some temperature thermocouples on it so that you can monitor the temperature of several different locations. There's no, it doesn't adjust anything, and it's, we've got passive cooling on the mixing system. So it's really just a monitor so that you have that data within your record if you want it. So we'll go to next on that. All right, so there's the review. That's the total of the information. You hit save, and that's it. So now that protocol is loaded in there. So that's the work you could do, while you do your optimization, you figure out how you want to run your protocols. Now, as an operator, you can come in and you're ready to run the protocol. You're just going to go pick that protocol that you just created. So that was protocol 37. You make sure that's what we filled out. Yeah, that all looks good. That's right. You could go through, check your sources. There's the flow rates we put in. There's our output sets individually by each individual output number. Sensors, we don't have any of that on, and it's not a formulation, so that's not really an issue. So I've got that pick selected. So now I'm going to try to move back here and see if I can hold this in a way that doesn't give everyone motion sickness.
And real quick too, while you're doing that, the tablet that you're using, is that something that comes with the device, or would we need to furnish our own, or would we be capable of furnishing our own device?
It does come with the tablet. To be honest, I'm not a fan of the Samsung tablet that we have. Any Samsung, any Android tablet works. We have the Microsoft version of the software, but it's not yet validated, but that will be available sometime in the near future. That would be my preference. I really like using like a Surface tablet.
Well, one thing we have some, I don't know what the manufacturer is, but we have some Microsoft or Windows-based tablets that we use that can go in the clean room and be wiped down and all of that. But we're able to use that instead. That probably would be good for us.
Yep, that is the idea, that's available soon. But yeah, you can use any Android tablet at the moment. All right, so see how this goes. All right, so I'm in a little bit close here. I don't know if you're going to be able to see this. Once I hit go, one of the things that's going to happen is that behind these sets, the fluid valves are all actually three-way stopcocks instead of pinch valves. And so the reason we went with that is because it allows us to reuse the fluid paths and move things in different directions instead of having twice as many or 3 times as many tube lines. It kind of simplified the process. So the first step, once I hit go, is all those valves are going to go from the default position to the position to run the protocol that I just started. So I'm going to go ahead and over on the software, hit run. It's going to ask me if I want bypass batch or batch active. The only difference on that is batch active. It's going to create the batch report, the protocol report, and automatically tie it to the audit report for the system. So there we go. Enter the batch number name. Just going to call it 5. Start batch. I'm going to move over here. There's a checklist step here to make sure the sources are connected, transfer consumables installed, output consumable installed, and the clamps are all in the correct position. If yes, continue to prime. Start. So I don't know if you can see those valves turning. Not really. Okay, so then what happened here was the system opened up so that it's going to pull from this line, the source 3 line, and it's going to fill 5 outputs, and it's going to do that all at the same speed. So back over here to the protocol, hit start. So the fluid is priming at a very slow rate, like we programmed it to. Fluid front is right about here now. So this bubble sensor was tripped. Now it's going to come over and it's going to hit this one and stop. So now the priming stopped. The fluid ran through the tubes all the way over here to the right of the output set. And then it's going to fill from the right to the left one at a time. Sorry, I didn't hit the button. So again, 25 mils per minute is actually pretty slow.
There's some that it drains it and it pulls it like backtracks.
Oh,
So there's no good one.
Yeah, so the observations that Thomas and Brittany are making looks like the dead volume is highly limited because it pulls the.
Exactly. Yep.
Pulls it back down. Pulls it back down.
And at
Wow.
the end, you have the option, for example, if you weren't using the entire volume in your source, you can purge all the way back into your bag, essentially clearing the line.
So what's the fastest rate that you would recommend for a 2 mil cryo vial to do a 1 mil fill?
You can go quite a lot faster than this. I think I typically, when I'm using BIOS, I'm going with something like 100 mils per minute, and
Okay.
and then bags 500. But you know, you really need, depending on what kind of cells you have. Most cells are a little more robust than people think in terms of the pressure at these speeds. I mean, most people aren't really pushing a syringe that slow if they're doing that, or a pipette, but that's one of the important pieces. Okay, so now those 5 vials all filled. Looks like they did a pretty good job there, so things look pretty good. I didn't really mix up the food coloring all that well, so there's clear over here to the red. And then it asks, is everything done? Are you done? If you're going to purge, so this purge is just between your first output set and your second one. So the idea there is that you're going to clear this line so that you have a dry line here to weld the second set to. So now the fluid front is all the way back here.
So you could be sealing those vials off as they get filled, correct?
Absolutely. Sure. Yep.
So when you get to the end, you seal the whole manifold off with the stubs and then weld your new one on. That's what you're going to do?
Yep. Absolutely. So I think personally, to me, I think the quickest way to process is once this purge step here to allow you to do the next line on, seal that, take that off, and then weld the next line on while somebody else is going to take these and do whatever processing. But there's a lot of ways you can do that. Okay, so now the next step is to change that output set. So I'm going to set this down and do that. The lines are weldable, but I'm not going to weld today. I'm just going to use the piece or the lure connection that's on here. What was that hinge valve? That hinge valve. Pull that off. So then this is where you would take this off. And that goes downstream. Place on the next unit. In this case, these are 15 ml bags. I jumped ahead in the protocol, so It's moving the valve set to the next position to put the next set on.
Do y'all sell manifolds that already have vials connected to them?
We do. Vials and bags and weldable PVC pigtails.
Is that by chance available with the 5 ml vials with the long lead on them?
I'm sorry, what was the question?
You have the 5 ml cell seal vials that have the long tubing that's on them that's
No,
wound
not
up?
yet. No,
Okay.
not yet. That product, we're still going through the final validation on the on it. So we've got a little bit more testing that's going on with that product. And
Okay.
then, you know, sort of that will be a downstream process. All right, so samples, new second set is connected. That's really all you have to do. Make sure the clamp is back open. What do we got here? Everything's okay. Go back to the protocol. Is everything connected? Yes. See if you guys are seeing it okay now. Should be able to hit start.
Do you have leachables and extractables data for this? What's the percent DMSO and the exposure time for the kit?
Amy, do you remember what we have specifically on this? I know off the top of my head, remember exactly what we have in hand on that. The DMSO, obviously with PVC, is potentially an issue, but so far, anything that we know in terms of changing the performance of the tubes, we haven't found any problems. The residence time is pretty low. In terms of extractables, I have to double check and see what data we have. I can't remember what we've collected on this. Okay, so in the second round, just like the first, again, it primes all the way over here so that it's going to back the fluid out just like the first time. Prime is complete. Yes, so here now it's going to go start the second fill.
On the software, if you notice that there's a leak in the manifold or a leak in the weld after you've attached a new manifold, is there an emergency stop? An abort mission?
Yes, there's emergency stop on the right. That's just a hard power kill. And then the software has a stop and reset button on it as well. So you can stop it and make adjustments using both methods. The e-stop will kill the whole thing and that's it on the protocol. The other will give you an option to start stop if you can fix it.
Okay, and the start stop on the program is more of a pause?
Yeah, that's what I meant. Yep.
Okay. Just making sure it would resume if something should happen.
So it's gonna fill first and then you're gonna go back to evacuate the air?
Yeah, we can do, well, actually on this unit specifically, the engineer's unit, the air removal pump isn't working quite right, but I can show you the concept anyway. But yeah, it'll fill and then you can go back and do air evacuation.
Okay.
And then we set the purge rate really slow, if you remember. So that's one of the reasons it's going a little bit longer between, but.
Do y'all make the cryo bags or do they come from somebody else and you'll just incorporate it into manifold?
We use the charter medical bags. So those are the ones that we have available. If you already have a different bag that's validated, we'd recommend the DIY set for the outputs because those have a weldable pigtail on them that you can you can create your own consumable using that bag.
Okay.
All right, so then that's that. I'm gonna adjust here again to try to get set to the air manipulation.